Well, good morning and good afternoon, everybody. My name is Jesse. For those of you joining us for the first time, of which there are several classes joining for the first time today, we are all about bringing conservation, adventure, and science into classrooms around the world. And you're catching us in an exciting day for two reasons. Number one, this is the third of our triple header. This day sort of epitomizes what we're all about as an organization. We started off with Paul Sokoloff in Ottawa, talking about his amazing work going up to the Arctic for botany and biodiversity studies. We just wrapped up with Anna Blakeney in BC, talking about her incredible work on mRNA vaccines and becoming like a TikTok star, talking about all that with the public. And we get to wrap up today, and for the second reason it's very exciting, with one of my very favorite scientists from last year, Dr. Lauren Erland. She's joining us at the University of Fraser Valley in the Chilliwack campus in BC, one of the most beautiful places, not just in Canada, but the world. And she is one of the very rare people that is as enthused about her job as I am about mine. That does not happen very often. So today, she's going to talk about her amazing work with the Berry Lab. She's live in the lab. We've got pictures, we've got videos, we've got props, we've got everything to show you today. So without further ado, thank you for joining us as we get to continue to celebrate the amazing world of botany and plants. It's not necessarily as romantic as volcanoes, but I promise you it is very, very exciting. So, Lauren, thank you so much for joining us today and welcome back to the broadcast.
Thanks, everyone. I'm so excited to be here. And hopefully by the end of this, I can convince you actually that plants might be just as romantic as volcanoes. I'm just saying. So can you see my slides okay, Jesse?
We are golden. If you just go full screen with them, it'll be perfect. And I know the videos are giving a little trouble, but that is awesome. Thanks, Lauren.
Okay, perfect. Okay, so I want to get you guys to help me answer a question today. So today I'm in my lab, which is where we do all of our plants intelligence work, all of our plant environmental response work. And I want to ask you to help me answer the question, do you think plants are intelligent? So just right off the bat, Jesse, maybe you can help me. If anyone wants to put in the chat, what do you think? Do you think plants are intelligent? Are they not intelligent? Are they just the carrots you eat? Are they smarter than your baby sister? What do you think?
Thank you for those analogies of all things. So YouTubers, StreamYard, please feel free to put in the chat. We've got our early answers are, we got some yes, we had a couple no, so we're mixing. So your big thumbs up sort of gives away the game, I think. I must say, like instinctually, before I've been reading a whole bunch of cool plant stuff lately and talking to some amazing people like you, my instinct would have been no. It's the carrot that I eat, not intelligent at all. Now we've got they're super intelligent. So the crowd is really getting behind you, Lauren. This is fantastic.
That is great. I love it when my own bias manages to contaminate the entire sample. So great. I'm super proud of all of you. So if we want to answer this question, I think the first thing that we need to talk about is what is intelligence? So if we think about how do we define intelligence, you might think about how is a person intelligent? How do we decide that your pet dog is intelligent? How do you decide, again, if your sibling is intelligent? We can use different definitions. And so these are a couple I pulled off the internet. So you have the ability to acquire knowledge and skills. You can solve problems. You can learn. You can reason. And to me, a lot of these things all come down to actions. So they're behaviors. They're things that you're doing in response to something that's happening around you. And so if we think about how are plants intelligent, let's use some examples. And when we use examples of plants, we can think about different things plants do or plant behaviors. We call these tropisms. I know we've talked about this with Jesse before, but plants have so many more senses than we do. So this is just 13 of them, and this is not the whole list. But plants they can see, they can feel gravity, humidity, temperature, all sorts of crazy things. So let's break this down into senses. So can plants see? So we call this phototropism, so seeing light, scototropism, knowing when there's not light, or you can even think about heliotropism. So this is like sunflowers that follow the sun over the course of the day and they know where to look. And so this is where our videos go sideways, but I'm just going to open this up. This is some watercress seedlings. At the beginning of this video, the light is all coming from one side, and then in the middle of the video, it's going to shift. So we're going to watch and see if the plants move here, just like we might expect a person to. Okay, so we're watching our seeds. They're sprouting now. They're growing. The light is, for me, on the left-hand side. They're moving towards the light. And now we move the light, and look how quickly they shift. Okay, so plants, I think this is pretty definitive proof that plants can, in fact, see. They can see light. And more than this, they can see different colors of light. So sometimes plants will have preferences and they'll grow differently depending on the color of light. So not only can they can see in color. Okay. Plants can also smell and talk. So here's part 2 of my argument. So if you're a plant and you're being attacked by caterpillars, you don't want to get eaten by caterpillars because you want your leaves. That's how you make all of your food. So what plants do is they will start sending out smells. And these smells do 2 things. One, they tell the other plants around them that, help, we're being attacked by caterpillars, get ready. And the second thing they can do, which I think is totally crazy, is they can actually mind control insects. And they can call out to the insects and they can say, hey, come and help us. So now you've got 2 plants on the side that are smelling and saying, I think danger's in the air. And then you've got another plant that's calling in for help. So they're smelling and they're talking. And this is the first example is plants talking to be nice, but sometimes plants can also play not nice. And so sometimes when plants are in a situation where there's maybe not enough food for everyone or they're just being greedy, plants can actually start to talk and kind of like badmouth each other. And they'll emit other compounds and chemicals that will prevent other plants from growing and make the other plants smaller so that they can get an advantage. I think that's pretty smart. Okay, plants can also feel. So now we're thinking about our senses. So we can smell, well, I guess talking isn't really a sense, but we can see, we can communicate. What about feel? So I think most people maybe have seen a mimosa plant, but this is what happens when you touch these sensitive plants. And this isn't sped up at all. So you touch the end of the plant goes, I don't like that. Maybe you're an insect. Maybe you're trying to be a bug to eat me. I'm going to close all of my leaves up so that I'm harder to eat and the bug will fall off of those leaves. So the plant is feeling here. We can also look at what happens when it's not a person touching it, but actually a caterpillar. So this is a video of a plant. You're going to see a caterpillar is going to come in. It's going to munch on a stem, and then we're going to see the plant light up. So what's lighting up is actually signals in the plants. The same way our nerves would have nerve pulses when you touch us, when you feel your hand, the plant is going to do the same thing here. So let's just wait and see what happens here. So, okay, we see the caterpillar, it's munching, and all of a sudden everything glows. So the plant isn't just kind of sitting there and passively waiting for the caterpillar to eat it. It's saying, we're being eaten, do something. Should we watch it one more time? I think it's pretty cool. There it goes. Everywhere it lights up bright green, that is the plant sending nerve signals and impulses, just like we do. And plants are amazing because they also use this, because they use the same signals we do, we can apply some of those signals. So without even the insect, we can just put on a neurotransmitter on a plant. So in this case, glutamate. And it will do the same thing just as if the caterpillar was eating it. So where the arrow's pointing, the scientists put down a drop of that neurotransmitter. And look at that, the plant lights up. How cool is that? Okay, let's watch it one more time. Go back to the beginning. Okay, so there the glutamate goes on. So there's our neurotransmitter. The same thing that would make signals in your brain is making signals in these plant leaves. It's telling the plant that we're being eaten here. We've been damaged. There's some sort of trouble. It's time to get ready. It's time to prepare. And plants actually, when they do this, I'm showing you this just once, but if you do this enough times, plants will learn from this and they will start to send their signals quicker if there's always a danger after they see that signal, or if they get that signal a few times and then nothing bad happens afterwards, plants will start to slow down how they respond. So just like you, if I slam a door really hard and you get startled, the first time I do it, you're going to get startled. But if I do it like 4 or 5 times in a row, then I'm just annoying and you're going to ignore me. Plants do the same things just like this. And how do plants do this? So I mentioned some neurotransmitters or neurohormones. What do those actually mean? Maybe these are some things that you've heard of before. Anyone heard of any of these? So melatonin, serotonin, adrenaline, dopamine. Do you recognize those, anyone?
Sure do. Melatonin, well, you got the Z for melatonin, and I think that's the one that we've actually talked about in other broadcasts before, where people know that that is sleep now. Adrenaline's also a pretty big one, sort of you think of getting pumped up, excited for things. Anyone who wants to chime in the chat with any of these too, but yeah, some are pretty known, and serotonin maybe a little less so. Yeah.
Yeah, so Jesse, you've got it totally right, and interrupt me if we've got any comments from the chat. But melatonin in people, it makes us sleepy. Serotonin makes us happy and excited. Adrenaline, of course, is our fear response, and dopamine is kind of the love hormone. It makes us it's all the feel good things, but also the same thing you get from your screens, apparently. So plants don't necessarily feel sleepy or happy or fear the way that we do, but they make all of these same compounds, and they use them when they're stressed out. And so things like melatonin and serotonin are actually, if anyone's heard of something called antioxidants, they're what the superfoods in all of our berries. And what they do is they help protect our cells. So when our cells are really stressed out, they have all these oxygen molecules that run around in them and start damaging bits and pieces of our cells. And all of these compounds, melatonin and serotonin, can actually go, and they're super fighters against those. But they also do things like control those signals we just saw. They can control basically the equivalent of nerve firing in plants. And so in plants, they don't have nerve cells, but they do have lots of vasculature. They've got lots of veins in them, and that's how they can send all of these signals. And so it's really crazy to think about, like, why do plants have adrenaline? They're not like, having a fight or flight response, but if you think about it, we can do fight or flight because we can actually get up and run away. But what plants can't do is the runaway part. So they have to be really, really, really good at fight. And so having all of these different signals is really important for them to understand very specifically what is going on around them. So here's a little diagram of how plants might do this. So we have all these hormones that sense different specific things and help plants fine-tune their response. This is one of them. It's called auxin. It was actually discovered by Charles Darwin back in the 1800s, which I think is just crazy. And what happens when you're in the light? So if you've ever seen a seed germinate, it kind of germinates going up, but it kind of moves when it's going because it's trying to find where the light is. And so you can see that when the light is straight above, the auxin is kind of all straight above, but as the light shifts, this signaling molecule moves, and it moves away from the light, and that helps tell the plant that I need to start bending. And it makes that change pretty quickly, like we saw in some of the videos. That plant can move within, an hour or two. And so plant hormones control all of these movements in plants, even though when we think about it, we think about plants as staying very still. And so in my lab, what we're really interested in is knowing how plants understand their environment, because if we know how plants know what's going on, then we can understand how to help them. So because I said before, plants can't get up and run away, all they have is this kind of chemical warfare of understanding what's going on and responding with these very fine-tuned chemicals. And it's funny that Jesse said Paul was on earlier, because this is actually a picture from the Arctic that I was up at Beachy Island, where the Franklin Expedition graves are, this past summer, looking at plants. So it's a great place to go check out plants and climate change. So Jesse, I'm going to stop sharing now, and I'm going to show you some of the plants we have in our lab here and how we can actually study these things.
Let's go check them out.
Let's check it out. Okay. So behind me, this is actually our plant growth room. So this whole room is specially controlled for the perfect environment for plants. We've got different colors of light. So you can see behind me, that's a little bit more blue and purple. And this can actually make plants flower, whereas we've got more full spectrum light over here. So this is all white light. And this one can help plants grow just kind of like more vegetative growth. So this is an example of plants being able to see different colors. And behind me, it looks like I've got plants in baby food jars. And what this actually is we can grow our plants in a completely controlled environment. So we take them out, we don't let them grow in soil anymore. We have them in this kind of space gel. In this gel, we have all the sugars and the nutrients and everything that a plant might ever dream of needing. And it's perfect recipe that's optimized for each of these plants. And the reason this is important is now every single plant has an identical growing environment. So if we want to understand what each one of those separate signals do or separate hormones do, now we can control just that hormone. We can put in a drop of melatonin and we can see what happens to the plant. Or what we can do, and I've got some Arctic plants here with me that I was just showing Jesse before the broadcast. So these are, I wonder if we can see it, if I get it close enough. Can you see those?
Yeah, they're fantastic. I'll make you full screen again. But yeah, little green guys. They look like sort of like a weed that I'd see on top of the water somewhere, like a duckweed is where my mind goes.
Yeah, so these are basically weeds. They're chickweeds, but these came from where that picture I took and showed you earlier, up on Beachy Island and Resolute. So that's on the Northwest Passage. So we brought the plants all the way from the high Arctic, and now we have them here in Chilliwack, which is almost as far south as you can go in the opposite direction in Canada. And so we were able to, first of all, grow these plants somewhere where they're totally not happy. But we also have these plants that can grow in this super specific extreme environment. And now we can understand what happens with each of those variables. So normally they would have high wind, they would have cold temperatures. They actually have 24-hour daylight the whole time they're growing. If you think about your plants at home, if anyone's mom starts seeds at home, you think about the lights don't stay on all day. You turn them off at night normally, but these plants stay awake all day for 24 hours a day the whole time they're growing. And so we can change each one of those environmental conditions on its own. And by doing that, we can then understand which of them affects how the plant grows. And the other thing this is just a warning for everyone, bad things are about to happen to plants. Well, what we often do is we take the plants and we stress them out as much as we can, and then we kill them. And the reason we kill them is to understand what's going on. We can measure all of those signals in the plants. And so we can say, this specific melatonin is really important when it gets cold, or this specific serotonin is really important when it gets hot. And so this is the kind of like exciting thing that we can do in our lab. And so, Jesse, I think I might have talked too fast because I was so excited, but hopefully we have some time for questions, and I'll show you a couple more plants first. So if I show you this one, does anyone want to guess what this is? It might look a bit familiar.
Ooh, he's tiny leaves. I mean, see, when you say he should look familiar, now I'm on the spot and now I'm nervous. But if anyone wants to chime in the chat, if you have any thoughts, oh, come on. I mean, like, no,
yes!
not over.
The
What do we
first
got?
guess, you got it right.
Strawberries.
Amazing.
St. Luke's, bow down. I honestly had no idea. I was going to stall till someone got it, so that was good. That's beautiful. Thank you, guys.
Do you guys want a job? Do you want a job in a plant lab? Come visit me. Okay, I feel like I made it too easy. Maybe we could do one other one. What about this one? What do you think this is?
You know what, St. Luke's, if you guys want to flick on your mic and camera, I can bring you in to say this live. We can make Lauren big, and then you guys can come in and just yell it out if you want. Or YouTubers, let's see, 6 7s, what do we think? You can unmute. Come on in.
Is it Dill?
Is it
Dill?
Dill?
Dill? It's not dill.
I'm kind of happy you didn't get it right the first time on the
I was
second
gonna
try.
be so impressed if you got both of them. The other thing about growing plants this way is they always look a little bit different because we've grown them in miniature. We've shrunk them down, so everything is like tiny and doesn't quite look normal. So, do you guys have what? Do you want to try one more guess?
One more guess.
Is it garlic chives?
Garlic or
that is
chive?
a very good guess. It looks very similar. I agree with you, and I have an advantage because I get to look at it in full resolution here. And so, what it is it's actually an invasive grass here in BC. And so, we want to understand not only how do we help the plants that we want to be here continue to grow here, but also if we can understand what lets invasive species that we don't want here that are coming in grow well, then we can maybe target those and slow them down and discourage them a little bit from growing in. So we actually have some invasive species like this. This is actually a cheat grass. So, but I think it looks a lot like garlic dill now that you guys say that. So
can I say too that the fact that we have students in grades 6 and 7 that their mind goes to dill, garlic, and chives, you guys eat so well there. Like, way to go. Like, when I was your age, I have no idea what any of those things are. So I appreciate you immensely. Lauren, how many plants total do you have in the lab? I mean, this is a leadoff question from me, but is there like a set amount that's behind you that's sort of off camera? Is it 10,000? Is it 50? Is it, what's the deal?
ooh. Okay, I'll see if I can, so we've got a few empty shelves right now, but we've got all these plants here, and then there's more. Can you see that bin down there?
Yeah.
Those are all more seeds that we've got started germinating. So we've got more than 150 different species in the lab. We're not using them all at any given time. So we store the seeds sometimes until we need them. And then other plants that don't do well as seeds, we'll keep them in this gel media, but we'll keep them in kind of a dormant setting. So we'll kind of put them into, you know, when they like have the sci-fi documentaries where they put the humans in like the little capsules and put them to sleep. We'll do the same thing with these.
It's literally what jumped to mind when you showed me that, because I've never seen anything quite like that in my career and in fiction or nonfiction or anything else. And so how did you come up with that gel medium? Like, is this something that you created? Is this something that's been around for 100 years? Like, how do we even conceive of this?
Yeah, it's a great question. So the very first people who did this actually did it using coconut milk way back in the 1960s. They made the first recipe. So we've been doing this for quite a while, but every time you get a new plant, you need to make a new custom recipe for it. So it's just like trying to make a really good batch of cookies in your kitchen. You start with a recipe someone else has given you, and then you just tweak it a little bit every time, one thing at a time, until you figure out what kind of makes the best tasting cookie, or in this case, what makes the plant grow best in the way you want it to grow. So we can actually, in addition to just studying how things different, like hormones change and environmental stresses change, we can actually grow up tons and tons and tons of plants. So we can say, plant, I want you to just make new shoots. And so we can have thousands of plants in a single box. So this box probably has 1,000 individual plants in it. And we just have to separate them out and root them. And then you could plant a whole garden with these if you wanted to.
Very cool. Thank you, Lauren. By the way, our class at St. Luke's, they're probably making all these cookies all the time with their knowledge of food. So kudos to you guys. Ms. Whelan's class, if you do want to come on in, you can flick on your mic and camera anytime. You're in the background. We'd love to take some questions live from you YouTubers. Please keep sharing. We have lots of time for Q&A together, so lots to explore and discover. Anything plants you want to know, anything about Lauren's work. Specifically, you talked about going up to the Arctic. So we had a class asking about what that journey was like, how often you get to go there. Tell us more.
Oh, yeah. Okay. Going up to the Arctic was super fun. So I've only been up twice now. So I got to go up in 2019, and that's where we kidnapped the plants I showed you earlier and brought them back up with us. And for that, we actually flew up there. So for us, we flew to Iqaluit, and then we went all the way up to Resolute. And that was really cool. We got to do some different plant collections and, do a lot of the similar type of stuff that Paul does. It's just that instead of taking things back to, preserve in the museum, we bring them back to do experiments on them in the lab here. This summer, I had a chance to actually go up with an expedition cruise company, and they take scientists and researchers on board with them, and you actually get to cruise up through the ocean. So we went from Greenland all the way again back up to the Northwest Passage there and back down. And for me, that's really cool because we get to do north-south. So, as you go north-south, you have different climates. And so it's really, if you ever get to go, would definitely recommend.
Canada's got some pretty special places to explore. We've actually had a lot of speakers on this year that were on expeditions like that, including one that was right after yours. So we got the chance to talk about this personally. So it's a really special part of the world, and Canada has so much up there that people don't know. We talked about this with Paul earlier too. People don't think Arctic and plants. That's just not a connection that people naturally make, but it's teeming with some of the most incredible wildlife on planet Earth. And lucky for us to get to hear all about these stories today. So thanks, Laura.
Yeah, everyone thinks about polar bears when they think of climate change in the Arctic, but there are no polar bears or foxes or any other cute and fuzzies if we don't have plants up there. So
there's no better message than that. 6-7, come on back in. There's like a whole horde of you by the camera. I love it. Come on up. Ask your first question. Hey, guys. But unmute first.
Do you grow any poisonous species of plants?
Ooh, I love that question. So yes, we do. The really cool thing about poisonous plants is that in low amounts, poisonous plants are actually medicinal plants. So almost anything that's medicinal, if you eat too much of it, can be poisonous. So yeah, we've got a few different ones. I don't have any that are growing that are like super poisonous right now. We usually only grow them if we need to, but we also use just the poisons from plants sometimes. So a good example of a poison from a plant that's also a neurotransmitter is things like atropine or strychnine. If you've heard of those are actually plant poisons that can change how plants grow. So that was a really good question.
It is a good question, and I love that in your talk you mentioned that we have the opportunity to fight or flight, and plants don't have that, so they're the chemical masters of the world. Like pretty much every medicine, every cool chemical that we've ever used for anything comes from plants in some fashion, and it's because they've developed all these strategies for combating everything that wants to eat them. So I think that's such an important message for our kids to take home. So cool question, guys. Lauren, you know what? It's been a long time since we've had like a horde, like a lineup in the classroom. So I'm going to go back to them a few times in a row just because I love that you're so enthused. Come on back in, guys. Take us away. Hey.
How many different recipes of gel did you make?
Ooh, so almost every single plant in here has its own special recipe. So if I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 10 different species of plants just on this top row, and they'll each have their own kind of little bit tweaked version of the recipe.
Interesting. I can't believe that you have the amount of trial and error to get to a point where you know what each plant needs is wild, because I don't know if it's like bacteria. I've done minor bacteriology back in the day, and like it's really hard to get bacteria to grow in a gel. Most do not. So the fact that you can take plants from the middle of nowhere and bring them in and design something that can sustain them is really fantastic.
It is really cool. And I will say the other cool thing is, so we tweak the recipe so we can get like the best possible growth for plants, but a lot of these plants will do okay if we just use kind of like a basic recipe. Like no one hates a basic chocolate chip cookie, right? So if we just start with a chocolate chip cookie for all the plants, they will do okay. It's just that some plants prefer their chocolate chip cookie with some butterscotch. Some of them prefer it with raisins added in. But there will be a lot of them will be okay with the very basic recipe. So it's a really good question.
I think the raisin people should be shunned from society and never allowed back in. We'll
Controversial opinion.
I've got an abominable snowman cookie jar full of normal, perfect cookies just downstairs, I've got to say. But we'll talk after the broadcast. St. Luke's, come on back in. Take us away, guys.
How high can a plant grow?
Ooh, good question. So plants are really cool because unlike us, plants don't stop growing. So plants can keep growing and growing and growing until they're restricted by their environment. So if you think of like the tallest trees, the sequoias down in California, they grow as big as like office buildings, right? But different plants have adapted different strategies. So a really cool example of that is our little Arctic species. So these plants, when you see them growing up in the high Arctic, they're really, really short. They only grow about this tall. But if you bring them down here and you give them light and you warm it up a little bit, not too much, you find that they'll start to grow quite tall and they'll start to stretch out. And that's an adaptation and a choice they make based on the environment they're in. So up there, it's windy, it's cold. If you think about yourself when you're cold, you kind of like huddle in to stay warm. Plants actually do the same thing. So they'll put on a winter blanket. They'll grow fuzzy kind of hairs on their arms. They'll grow really small and tight. And that's one of the reasons they follow the sun too, is that concentrates the heat of the sun towards them. So taller isn't always better. Plants will make the choice depending on their environment, but they can grow really, really, really tall.
I love that you highlighted the winter plant thing, because you'll know this, but for plants that live on mountains, they'll often keep their leaves, like they won't shed them, and they end up with sort of this like fur or fuzzy coat, and it's so cool. It's one of the most amazing things I've ever seen in nature. On the sequoia front, if you haven't looked up a sequoia, they're amazing. They can be 10 times the size of a blue whale. They're like the biggest thing on earth. This is an acorn from one, which is one of my prized things that I have. I really like that I own this, and that
is amazing.
They're very fun.
We didn't plan this in advance.
I promise we did not. England actually has more sequoias now than California, which is really surreal, because people used to bring them there and like plant them, and then they're like, oh, I've got a sequoia, I'm a rich man. And so now there's so many growing there with the climate shifting there and shifting in California as well. There's your surreal plant knowledge of the day, students. I can't believe there's a lineup. This is so great. You know what? We'll take one from YouTube in a minute. I'm going to head back to our St. Luke's class for a bunch. And St. Luke's, you can keep your mic unmuted when you're in the background. We can't hear you anyway, I promise. So come on up.
Do lab-grown plants eventually get kind of sick of the sun? Like, does it burn them?
Interesting.
Oh my goodness, that is such a good question. Okay, so bear with me because I'm very excited about this one. So in the lab, people used to think that the plants didn't actually do photosynthesis when we had them in the lab like this, because one of the things we give them is sugar, so they don't have to make their own. So you're 100% right. The lights behind me are way dimmer than the sun. And so the plants we have here, they do a little bit of photosynthesis, but if I took this out and I put it in the full sun, it would 100% get burned. It would totally freak out. All the leaves would turn like yellow and red. And so that is the plant trying to put on sunscreen to protect itself from the burning. So if we actually want to take these out of the lab and put them back out in the field, we have to do kind of like an acclimation step where you slowly bring them out a little bit at a time so you don't burn them. So you're exactly right. You guys are some amazing scientists.
I gotta say, like, all the questions have been really, really good. That's like a question that like a high level lab would ask. Like, that's a really neat bit of inquiry. So thank you very much for that, man. YouTube, we're coming to you guys in a second. Come on back in. Let's keep the train going. Hey.
What was the first type of plant did you tend, and how did you tend it?
Ooh, that is a really good question. Let me think. Okay, so it was probably when I was a kid in my mom's garden, and we always had pansies. For some reason, I remember there always being pansies, which are just like little purple and yellow flowers. And I suspect I didn't do a very good job of it, if I'm being honest. I think you guys would probably grow plants better than me. I do joke now that we grow a lot of plants, but we also kill a lot of plants here. Because the only way to find out how they live when they're stressed out is to stress them out so much that you know like what the brink of death is. So you maybe shouldn't invite me to your garden.
Don't worry, we'd already banished you. The rest of the house for grabs, though. I love the idea of stressing something out until you kill it, which is a lot more pleasant in the plant context than other biology necessarily, but it's fantastic. Oh, I'm having so much fun in this broadcast. Professional detachment is out the window as it was before with you. YouTube might be an easy one, might be a really tough one. Is there a favorite plant? Do you have like the go-to Lauren's favorite plant you beat people over the head with how cool it is all the time?
I always get this question, and it's like the most controversial answer that I have because we mostly do berry research. So everyone expects me to answer with a berry, but I think willows are really cool. So willows are really cool because the student who asked the question about how tall the plants grow, it comes back to that because a willow, you can think about it if I'm like, look around here in Chilliwack, there's beautiful tall willows that are the size of a building. But if you go up to the Arctic, there are willows that are the same size as this little tiny weed that I was showing you. They don't grow more than this high off the ground. And actually, the smallest tree in the world is a species of willow, and it is smaller than these strawberry plants that I'm showing you right now. The leaves are like 1 centimeter tall. There's 2 of them, and it's called snowbed willow, Arctic snowbed willow, or Salix herbaceae. It's teeny tiny and it's still a willow. Is that not the coolest thing ever?
So we have zoo programs regularly, and they'll be like in front of the gorillas, and kids will ask, "What's your favorite animal?" They'll be like, "The giraffe," and you just know the gorillas like just appalled at this, right? Now, you talked about plant sensors, and I want to highlight you didn't cover absolutely everything today. You covered a lot, the new information for kids. The Light Eaters is my book that I recommended to you before the broadcast. For our teachers, certainly is just an amazing take on plants. But part of it is that in some fashion, they can hear and understand sort of to some degree what's going on. So what I'm saying is that you really profoundly upset your berries with your willow story, is the moral of the story.
Well, okay, so here's my theory on that. We know plants can hear vibrations. They can sense vibrations, and that's all sound is vibrations. It's a bit of a spoiler alert, I suspect, for the book. But they can't necessarily understand language. So I think I'm still okay.
Okay, we won't vibrate in the way that they can understand, and that's the key.
Only good vibes.
Only. St. Luke's, come on back in. We'd love to have you back. You can unmute. You turned off your camera, but you don't need to disappear because we like you guys. Hey.
Since plants can like move, if one plant gets too close to the other, can it like take over the other plant?
Oh, cool.
Yes, great question. So plants will do a few different things. So if you've got a really fast moving plant and a really slow growing plant, then you definitely can have that happen where we would call it out competing. So they're in competition with each other, and the really fast growing one will take over the smaller one, but plants will also see that other plant coming and be like, whoa, personal space. And the other plant will start to move away from it. And so you actually see this if you go and you go for a walk in the woods at all and you look up, a lot of the times the trees will actually not have all their branches touching. There'll be a little tiny gap between it, and it's called crown shyness. So some plants play nice with others and will kind of like have a cordial agreement. And then other plants, like I'm thinking about like the invasive blackberry plants in my backyard, and they're just all over everything. They don't care. They have no respect for boundaries. So it depends on the plant.
I'm so glad you mentioned crown shyness. This is like a really neat thing. And honestly, kids, next time you're in a forest, go walk around and look up and you see the trees aren't like flopping all over each other by and large. Like that would be a really weird thing to have happen. I can't think of it in my sort of local neck of the woods. So the fact that we got to cover that is awesome. St. Luke's, I'm going to say too, because we are nearing the end of the broadcast. You guys are so inundating us with questions. Write down anything you have at the end. We're going to take 2 more, and then we'll pass it along to Lauren, and we'll get you the answers after the broadcast. She's like so keen about all this, so please do write down any extra ones. YouTubers, you too. But we'll come in for 2 more live. 6 7s. Take us away.
What is the most common invasive plant?
Ooh, that has got to be the hardest question you guys have asked me so far. And in part, it's because it depends on where you are. So you'll have very common invasive plants based on ecosystem. But I find the most common invasive plants tend to be the plants that humans really liked for some reason. So one example is a medicinal plant I did a lot of research on called St. John's wort. If you Google it and you go look around, you probably find it. And this was brought over from Europe because it's a good medicinal herb. And so everyone wanted to have it in their garden, but it's also really, really good at spreading, and it makes a ton of seeds. And it can grow in all sorts of different environments. And all of those are a really good recipe for a very good invasive species. So I don't have an answer for you for that one, but I can give you some kind of characteristics of it and an example of one that I definitely see around a lot.
Very, very neat. I've seen grape is a plant that when you see it out in the wild will like take over everything and have like giant tendrils like it's like attacking the other plants, which is sort of a very salient and obvious invasive species. Duckweed I've seen all over the world where it completely takes over entire ponds and it chokes out everything else. So it's a really challenging question. It really does. It depends on where you are on this planet. But invasive species is one of the biggest challenges for conservationists in the world, whether that's plant or animal alike. We had Susan Ching on in September talking about invasive species in Hawaii. She goes to like the most remote cliffs and helicopters down, and like the entire ecosystem's been taken over by invasives on these remote islands. So I'm so glad we got that question to talk a little about it. So thanks, guys.
Yes, a great question.
All right, St. Luke's, one more question live. Write down your rest. Please do. Like, send them to us. We'd love to hear from you. And then we're going to wrap up and say a big farewell to Lauren after that. But come on in with one final query. Hey, guys.
What is your most exotic plant that you have currently?
Ooh, most exotic plant. Okay, depends on how we define exotic. So I think the Arctic plants are pretty cool and exotic because you can only get them if you travel all the way up to the Northwest Passage. And it takes quite a while to get there. But if we're thinking kind of tropical exotics and things that you might want to have in your house, I've got this one cool plant that we just started in culture. And if anyone has a fish tank, these are Bucephalandra. They're an aquatic plant that have become very trendy. And so we have some of these in tissue culture, and they're kind of cool because they've got really dark leaves with little speckles on them, and then all the stems are pink on them. So these are kind of a trendy aquarium plant, and I think maybe they're the most exotic, though depends on how you define, because the Arctic ones are pretty cool, but I'm biased. So it's a good question.
I like that you've highlighted your bias so many times over the course of the broadcast. And I think the joy of this is that no one can stop us. Like, we can be as biased as we want, because in exploring by the seat of your pants, that's what we're all about. So
It's a lot of power.
It is too much power, and there's no responsibility associated with it at all. Not like Spider-Man whatsoever.
Nope.
Lauren, before we wrap up and say farewell, and please do stick around with me after the broadcast is done, is there any final message you want to leave our kids with about botany, about the amazing work you get to do before we bring in our kids to say thank you and farewell?
Well, I think we can all just go back to our original question. Do we think plants are intelligent based on what we've talked about today? And if you do, go and spread the word.
Spread the word. St. Luke's, do we think plants are intelligent?
Yes!
Yes, that's what it's all about. Well, a huge thank you to you guys as a class. Check out berrylab.com. Lauren's on social media as well. There's so much more to explore and discover. If you're ever keen, The Light Eaters is an amazing book to learn more about all this. But we are going to say thank you and farewell, guys. Have a wonderful day, St. Luke's. You too. Thank you.